Somewhere above you right now, a tiny smear of ancient light is traveling. It has been traveling for 13.5 billion years. It left its source when the universe was barely 2% of its current age, before the Earth, before our Sun, before almost everything that exists today had any reason to exist at all. And in the spring of 2025, a telescope caught it. What that telescope found didn't just break a record, it broke something deeper, our confidence that we understood how the universe began. The question we're really asking here is simple. What was there at the very beginning? Not the Big Bang itself, but shortly after, in those first few 100 million years when the universe was cooling and darkening, slowly assembling its first structures out of hydrogen and helium and darkness. What formed first? How fast? And does what we've now observed match what our best physics predicted? For decades, scientists had a model, elegant, mathematically consistent, built on the best data available. It was wrong, or at the very least, profoundly incomplete, and one small, impossibly ancient galaxy just became our most powerful proof of that. Before we get to the discovery, we need to set the stage, because the scale of what we're talking about is almost too vast to hold in your mind. The universe is approximately 13.8 billion years old. It began with the Big Bang, and from that moment, light has been traveling outward in every direction forever. Here's the counterintuitive part. Because the universe is expanding, the objects that emitted the oldest light are now much farther away than when the light was emitted. The edge of what we can observe stretches about 46 billion light-years in every direction. The farther away something is, the more its light has been stretched by the expansion of space itself, shifted from visible wavelengths toward infrared and beyond. Astronomers call this redshift. A redshift of 1, relatively nearby. A redshift of 10, we are looking deep into the universe's childhood. A redshift of 14? A redshift of 14 is almost the beginning of everything. When we look at an object at that redshift, we are seeing light from a time when the universe was younger than it would later take just for our solar system to form. This is why telescopes like the James Webb Space Telescope are not just scientific instruments. They are time machines.
In April of 2025, a team of astronomers led by Rohan Naidu at MIT pointed the James Webb Space Telescope toward a patch of sky that had already been extensively studied, but never at these extreme depths. They were hunting for what they called miracle sources, candidate objects that might exist at extraordinary distances but had never been confirmed. Using Webb's near-infrared spectrograph, the team captured the faint light from one candidate and broke it apart into its wavelengths. What they found was definitive. A sharp spectral break, where hydrogen in the early universe absorbs nearly all shorter wavelength light, and alongside it, 5 emission lines from nitrogen, carbon, helium, and oxygen, all pointing to exactly the same answer. Redshift 14.44. This galaxy, now designated MAM Z14, shorthand for Mother of all early galaxies, had broken the previous record. The prior record holder existed 290 million years after the Big Bang. This one, just 280 million years, 20 million years earlier. In human terms, small. In cosmological terms, it pushes us measurably closer to the moment the very first stars ever switched on. But here is where the story gets genuinely strange, because it isn't just the distance that shocked scientists, it's what this galaxy looks like. MAMZ14 is tiny. Its effective radius is roughly 240 light-years across. Our Milky Way spans 100,000 light-years. You could fit 400 MAMZ14s side by side across just our galaxy's diameter. So, why is it so bright? At its age and distance, astrophysicists expected to see something small, dim, and simple. Instead, MAMZ14 is brighter than it has any right to be. That brightness is driven almost entirely by stars, young, hot, intensely luminous stars in the middle of an explosive burst of star formation. Not a supermassive black hole. Stars. And then there's the chemistry. The spectrum showed something else unexpected. MAMZ14 is unusually rich in nitrogen relative to carbon. In the present-day universe, that's a signature of ancient, ultra-dense stellar environments, globular clusters, relics in our own Milky Way. This galaxy may be dominated by extraordinarily massive stars packed into incredibly dense clusters, enriching their environment with elements that weren't supposed to be there yet. Lead author Rohan Naidu put it plainly. With Webb, we're able to see further than humans ever have before, and it doesn't look like we predicted, which is both challenging and exciting. Challenging and exciting. Two words that in science often mark the beginning of something enormous.
Let's be precise about what MAMZ14 breaks. The standard model of cosmology predicts how matter clumps together over time. Gas collapses under gravity. The densest regions form stars first. Galaxies grow gradually, over hundreds of millions of years. Under this model, the universe at 280 million years old should contain galaxies that are small, faint, and barely formed. You might expect to find a few, scattered and dim. JWST has now found that the number of bright galaxies at extreme redshifts is more than 100 times higher than pre-Webb models predicted. Not twice as many, not 10 times, 100 times. The study authors wrote, "This unexpected population electrified the community and raised fundamental questions about galaxy formation in the first 500 million years after the Big Bang." This could mean several things. Perhaps stars formed more efficiently in the early universe than our models allow. Perhaps the first stellar nurseries were more productive, more gas converting to stars faster. Or, perhaps, and this is the more disruptive possibility, our fundamental understanding of how matter behaves at these early epochs is missing something. Some ingredient in the physics, some process we haven't yet characterized. MAMZ14 even appears to have already cleared the neutral hydrogen that should have filled the space around it. Models predict the universe at redshift 14 should be almost entirely opaque with hydrogen fog. This galaxy seems to have already punched a hole through it, earlier than almost every theoretical framework predicted. The study authors noted, previously unimaginable redshifts approaching the era of the very first stars no longer seem far off. Previously unimaginable. Just a few years ago, finding a single galaxy at redshift 14 would have been considered extraordinary. Now JWST is finding them and suggesting there may be many more yet to come. The Nancy Roman Space Telescope, NASA's next flagship observatory, is scheduled to launch aboard a SpaceX Falcon Heavy in September 2026. Where Webb probes small patches of sky with extraordinary depth, Roman's field of view is 100 times larger. It will survey hundreds of square degrees, finding not dozens of these extreme galaxies, but potentially thousands. A sample large enough to truly test and rewrite the standard models. Step back from the numbers for a moment. Think about what this actually means. 13.5 billion years ago, a small collection of stars, compact enough to fit within a region 400 times smaller than our galaxy, blazed to life in the fog of the very early universe. They burned hot and fast and furious. They seeded their environment with elements. And then they died. What remained, what was scattered, merged, recycled, and built upon, is everything you see when you look up at the night sky. The stars in our galaxy, the atoms in our bodies, the carbon in every living thing on Earth. All of it traces a lineage back through billions of years of cosmic evolution, back through the earliest galaxies that coalesced out of primordial darkness. MOAM-Z14 is not a distant, irrelevant artifact. It is a page from our own origin story. Peter Van Dockum of Yale University said it simply, "This is the most distant object known to humanity." That title changes every so often, but I find it is always cause for pause and reflection. The light from MOAM-Z14 has been traveling for over 13.5 billion years, longer than the Earth has existed, longer than the sun has burned, longer than life itself has evolved on this planet. And it found us. James Webb caught that light. Its instruments recorded it. A number emerged, 14.44. A name was given, MOAM-Z14. And now, because of the strange and beautiful wonder of science, you know it too. The universe did not intend to be observed. It simply is. It has been for nearly 14 billion years, whether or not anything was watching. But we are watching now. MOAM-Z14 is not the edge of what exists. It is the edge of what we have found. So far. If this left you wondering about the first stars, or whether the Big Bang is as settled as you were taught, or just how far our telescopes might one day see, then you're exactly where this channel lives. Every video here is a door into the deep universe. Subscribe, and let's find out what's on the other side.